Hello, today we're going to take notes 2 called algebraic expressions. If you can please write down that expression in your notebook. Make sure again that at the top of your page it says notes 2 and the title algebraic expressions. This is an example of an algebraic expression. The definition of an algebraic expression is it is terms that are combined with an adding or subtraction sign. There is no equal sign in an algebraic expression. Notice there's nothing over here. It's not equal to anything. If it was equal to something, then it would be an equation. There are lots of different parts of an algebraic expression, and that's what we're going to focus on right now. The first part is called the coefficient. The coefficient is just the number in front of the letter. The 6 and the x are multiplying one another, being multiplied together. The 6 is the coefficient. The x is called the variable. Any letter in a math problem is called the variable. So 6 and x together, they make a term. 9y is also an example of another term. 18 is also a term. It's just different because it doesn't have a variable with the number. So again, 6 is the coefficient, 9 is another coefficient, and then there are two different variables in this expression, the x and the y. The 18 is a special thing called a constant. It's called a constant because it is by itself. It has no variable attached to it. All of these are combined again to make an algebraic expression, and this expression has three terms. There's a special kind of term called a like term. Like terms are when the variables match, when they have matching variables. To combine like terms, you add the coefficients. We add the numbers in front, and the letter stays the same. So when we do this example, this means that we have 4 x's. This means we have 16 more x's, and so our answer would be 20x. Notice again, the numbers come together, but the letter stays the same. It was x here, and x in the answer. We're going to do a couple of examples. If you can please write these examples down in your notebook. The first one, 13x plus 2x plus 6y. The like terms here are the two terms with a matching variable. So that's the 13x and the 2x. Y is a different letter than x, and so it's not considered a like term with these two. So we can combine these. 13 and 2 is 15. And then the 6y just tags along. I cannot put these together. This does not become 21xy. We cannot put things together that don't have matching terms. So this is my final answer. For the next one, this one can trip students up sometimes because this is an x and this is an x and this is an x, but this one has something special. That exponent says 2xx. This means this has two x's and these each have just one. So only the 7x and the 2x are like terms, not the 2x squared. So when we combine these, we put 7 and the 2, that's 9x's plus 2x squared. We can also rewrite this, and we can really rewrite many algebraic expressions by changing the order. These two are exactly the same. The commutative property of addition says I can switch the order and it doesn't change the answer. So these two are the same. You could represent this algebraic expression either way. This is adding two separate algebraic expressions, and to do that, we just look for the like terms. There's an 8x and a 2x, so 8 plus 2 is 10x's. And something cool about this is I can put the constants together. Constants are considered like terms. 7 and 3 is 10. Now I cannot put the 10x and the 10 together because the 10 is the constant, it has no variable, so they are not considered like terms because they don't match. This last example, I have x's and y's. So when we do this, I like to put matching shapes around matching letters. So 4x and 6x are the same, 3y and 2y are the same, and so I can put my x's together. 4x and 6x is 10x's. 3y and 2y are 5y. X and y are different letters, so they stay separate, and this is my answer. Part 2 on the distributive property is next, if you can watch that, please.